important concepts we need to be able to analyze circuits. So I think basically applied electricity really centers around these concepts. So something like short circuits, open circuit, and things. So now we are going to deal with short circuit, and I really want you people to understand the short circuit well, because if you don't really understand short circuit well, you might not be able to, you might have an issue solving questions. So what is a short circuit? A short circuit has practically zero resistance. So in class there might be other definitions, but we can just say practically has zero resistance. So when we say something is a short circuit, when a circuit is a short circuit, what makes it a short circuit? So a circuit is a short circuit, that means there's no resistance on that line. So basically, when there's a short circuit, when the current sees a short circuit, it just moves. So let's say for this circuit like this, let's say voltage, this is the voltage. So since there's a short circuit between B and G, there's a short circuit between B and G, so the current will just move all the way to, it will move, and when it gets to this node, and from our previous discussions we said a node is a point where current splits or divide. But when it gets to this node, instead of it splitting, since there's a short circuit, there's no resistance here. Basically, let's say the resistance here is basically like zero, it's less. So we can't say it's zero, but it's less. Since there's no resistance here, it will just decide to take this path, then this path, all the way back to the voltage source. So one trick I want you guys to use in identifying a short circuit is this. You see, whenever there's a short circuit, that means there's no resistance. Listen to this. So there's no resistance there, and basically there's a free path. It's basically like, let's say you are coming to campus, and the queue to the shuttle, there are so many people on the queue just fighting for shuttle. Then you realize that on the route the road is less busy, so you do, because you don't want to struggle with those things, you just pass through the place that there are not a lot of people there. Then you just get a chance and enter. I don't know if it's making sense, but yeah, I hope you understand. Like, current doesn't want to go through stress. That's how current is. The current doesn't want stress, so basically it always just wants a free path so that it can easily move and come back. So the concept of the short circuits, when we say short circuit, that means, let's say basically we are saying zero resistance, meaning our resistance there is equals to zero. And you know, from Ohm's law, V is equals to IR. So with the V being equals to IR, it gives rise to two things. That means the voltage in short circuit should be equals to zero, if you agree with me, because we'll have a value for I. Let's say if they give us a value for I, even no matter if I is 1000 multiplied by 0, our answer becomes 0. So basically, in a short circuit, the voltage is basically 0 volts. And I think I will do another video where I will do a simulation showing you why in a short circuit the voltage is 0. So let's say if you want to analyze this circuit right now, since we've identified that there is a short circuit in this circuit, basically the circuit will now become like this. If you're analyzing this circuit, it will now become like this, because this is how the circuit will now look like, because the whole of these resistors, if you're analyzing them, the whole of this circuit will not be considered, because when the current gets to this side, instead of it splitting, there's a free path here. I will not split, I will just pass through and come back. And one thing is that current through a short circuit is very large. It's very large. So it's like infinity, like it's very large. So that is one thing we need to know. So going on, I think when we take an example, you understand. So let's say this is our second example. You see that there's a short circuit here. So let's say current starts to flow from here. When it gets here, it comes to meet this node. And from our definition, we said a node is where current is placed. So when it gets here, current will not split, because at this node you realize that there's a free path here. It's just a free path, like it doesn't want pressure, so it just comes all the way back to this. So basically this side, let me use a different color to denote it. So this side of the circuit would not be considered in our analysis, this side. So let's say if I'm going to redraw this circuit again, so this the part of the circuit that will be considered in our analysis would be this R1, only R1. So meaning both R2, R4, R3, all of them have been short circuited because there's no current that will flow through them. It will not allow current to flow, because when the current gets here, it just diverts back all the way back, and it comes back. There's a closed path. Because there's a closed path, the current can flow. So it doesn't really have to go through the stress of the other resistors. I hope you are getting it. So there's a simulation. I have a simulation that I want to let us look through, and it will really help us understand. Just to take an animation and look at and appreciate the concept of the short circuit. So as I said earlier, I told you that on this circuit, the whole of R2, R4, R3, they will not be considered in our analysis because there's a short circuit here. When the current starts from here, it moves to R1. Then since there's a free path at this point, it just moves back and back. And one thing you have to know is that current can never be lost. Current is never lost. That is one thing, because if 10 ohms is leaving this side, that means when you add everything back, it should be 10 ohms. That is how it is. So current can never be lost. So all the way back. So I want to use this simulation to explain it better. So we have a circuit here. So you see that it started moving. You see that the yellow arrows going is the current, shows the current. You see that nothing really moves on these two resistors. That means they've been short circuited. Look at it. It moves all the way here to here and back, because there's nothing going through them. There's nothing going, because you see, if there was current passing through, you see, you would have seen this yellow lines moving down, but it tells you that no current is going through them, nothing. They've been short circuited and they are just there. So if you are analyzing the circuit, you only consider this resistor, because this and this have been short circuited. They've been short circuited because ideally when the current gets here, it should split. But the current realized that there's resistance here, which is a very high value, even if it was not even a high value crowd. Since there's a free path, let's just listen to it has like nearly zero resistance, because let's look at here. From here, this side, there's no resistor here. So even if I was going somewhere, this road is crowded, then I will just decide to come and take the road that is not crowded. Then I'll come back. No stress. You're making your life simple. So that is how current is. So basically, I hope this one helps you to really understand the concept. So, because you see that this one and this one, there's nothing flowing through it. So that's it for short circuits. Then we'll move to the second concept, which is open circuit. We'll be dealing with the next thing on our line is open circuit. So with open circuit, is a branch that has infinite resistance. So what it means is that, like, let's say there's a broken path. That's basically, in a layman's term, there's a broken path. Let's say there's a broken path where the circuit is not complete. So meaning current can't flow through it. That's what, when they say something is open circuit, that's why you should just come. There's a broken path, so meaning there's some breakage there that is obstructing the flow of current. So let's say let's say a bridge. If there's a bridge somewhere linking two communities and the bridge collapses, meaning you can't access the other community again. So there's a broken path. So in electricity, we call something like that is an open circuit. So this is the open circuit concept. So with the open circuit, this is how we denote it, open circuit it. So with this open circuit, what you realize is that when current also starts to flow from here, it moves here and it gets here. You know, current is very smart. That's one thing I want you guys to keep in mind. It's very smart. It's not like it wouldn't come and take this path, and when it gets here, you say, oh, it's open circuited, then oh, I'm going back. Because as I said earlier, we said current can never be lost. Current cannot be lost. That's one thing. So when the current starts flowing, then it gets here and it detects. It will automatically, before it will even get here, it will detect that there is an open circuit. Since there's an open circuit here, it will just divert all the current back here, pass through here, then back. So basically, in the open circuit, when you are analyzing this circuit, we only consider this. We can also redraw this. So if you want to redraw this to analyze the circuit well, you can just redraw it like this. Then, sorry, I know my resistance is not nice, but let's just manage. So we can just say it's only this resistor that will be considered when we want to talk about open circuit. So I have a simulation again to show you how it is. So basically, with that, you see, the current flows from here then all the way back. No stress, so there is no stress in itself from here all the way back. From here all the way back. It doesn't even come here. You see that it doesn't come there because there's an open path. Because when it comes here, the current will be lost, and current can never be lost. So it has to be complete. There's a closed path. Current flows in a closed loop. So that is how it is for open circuit and closed circuit. I hope you guys really understand it. Yeah, so thank you very much. And I think from here on, we are now well equipped enough to take on serious questions and answer them. So meaning if you understand this concept well, we can now take exam questions and past exam questions, and we'll try to see how we can answer them.